We are starting with algebra indices on indices. There are some basic laws of indices that we will write them down. Throughout the analysis of indices, we are going to apply such laws. The first one is law 1. Law 1 says that a raised to the power m multiplied by a raised to the power n is equals to a raised to the power m plus n. Law 2 says that a raised to the power m divided by a raised to the power n is equals to a raised to the power m minus n. Law 3 says that if you have a raised to the power m in the bracket n, it is not different from a raised to the power m times n. Law 4 says that if you have a multiplied by a b all raised to the power n is not different from a raised to the power n multiply to b raised to the power n. Law 5 says that when you have a raised to the power m over n, it is not different from a raised to the power m 1 over n, which is not different from a raised to the power m in a root of n. And then we have the next law, which is 6, says that if you have a over b raised to the power negative c, this is called negative index. It is very, very important. It is not different from b over a index positive c. The left-hand side is equals to the right-hand side. But at this time, the negative sign has been done away at the right-hand side. We were able to do so by reciprocating the fraction, by turning the fraction upside down, makes the negative index it goes away. So you can see that if you have a negative index like this, you can make it a positive index. But to do so, you have to reciprocate the fraction. And the next one is similar to this one, which is law 7, I will call it, which says that a over b raised to the power negative c over d is not different from b over a c over d. We have done away with the negative index at the right-hand side. By doing so, or before doing that, you have to reciprocate the fraction. So these are the laws that we are going to abide by and to work with them. Take your time to copy them. They are very, very important laws, honestly, that we are going to, use them to solve complicated algebras, algebra. There are some algebraic equations that we are going to use all these laws to, to solve them. Very good. Take your time, copy it. Yes. There are some algebraic equations that are very, there are some equations whose algebra are very complex. For instance, like this one, if you were requested to simplify an algebra like this, the best way to do it is to apply those laws. That we wrote them down, especially law 1 and law 2. To do this work, to solve this one, there is a strategy that we have to adopt in order to simplify this one. This equation that you see above is no different from half x 1 minus x raised to the power negative half plus 1 minus x raised to the power half divided by s squared. This equation, honestly, to start anything, you have to do what I call it cloning system, or in proper language, you may call it rationalization. How do I do that? I pick up this term or that term, whichever, but always the simpler term is the best. I pick up this term and then clone it here. 1 minus x raised to the power, this is positive half. Because I'm cloning it, I'll make it negative half. And I will do the same thing, 1 minus x raised to the power negative half. You see, this equation is no different from the one above. By any means, this one and this one can cancel. What I will do is I'm going to multiply this one to this term and multiply it to this term as well. And then the denominators, I'll multiply this one to this one. So this equation becomes half, but before that, okay, it is still the same. Half x 1 minus x negative half multiplied to 1 minus x negative half raised to the power negative half plus this term 1 minus x raised to the power half multiplied to 1 minus x raised to the power negative half. Good. Then all over x squared multiplied to 1 minus x raised to the power negative half. Good. So you can see that this one and this one, they're identical. So you remember law 1 says that a raised to the power m multiplies to a raised to the power n is equals to a m plus n. So this one and this one are identical. So use law 1. If you use law 1, it becomes half x, which is this one, 1 minus x negative half plus negative half. Then plus 1 minus x, the same law 1, half plus negative half, all over the denominator s squared multiplied to s squared multiplied to 1 minus x raised to the power negative half. Good. You can see that if you apply the law 1, we will now have half x negative half plus negative half is equals to 1 minus x raised to the power negative 1. Good. Then you can here you have plus 1 minus x half plus minus half is 0 all over x squared 1 minus x negative half. Good. You can see if we continue from here, we have 1 over 2 times x. But remember, if you have a fraction like, let's say, a raised to the power negative 1, it is the same as 1 over a. So this one, 1 minus x raised to the power negative 1 is the same as 1 over 1 minus x. Then, if you look here, 1 minus x raised to the power 0, any number raised to the power 0 is equals to 1. For instance, 5,000 raised to the power 0 is equals to 1. 20 raised to the power 0 is equals to 1. 45,000 raised to the power 0 is equals to 1. So, any expression that is raised to the power 0 is equals to 1. So we can see that the whole expression here is equals to 1. So it becomes 1. Then they have a common denominator, which is s squared 1 minus x raised to the power negative half. Good. This one is no different from 1 over 2 1 minus x times x plus 1 all over s squared 1 minus x raised to the power negative half. Good. You cross multiply this one. If you do that, you have x plus 1 times 2, this one, cross multiply to this, 1 minus x. Then the denominator at this time becomes 2 1 minus x multiplied to s squared 1 minus x raised to the power negative half. Good. Then it is not different from x plus 2. 2 times 1 is 2. And then 2 times minus x is minus 2x. All over 2x squared. You have 1 minus x, which is this one, and 1 minus x, which is that one, raised to the power negative half. You are still applying the law 1. So if you're applying the law 1, that says that a raised to the power m multiplies to a raised to the power n is equals to a raised to the power m plus n. So let us continue. I call this one section 1. I call this one section 2, so that it may not confuse you. Let's come to, I'll call this one section 3. Okay, in section 3, we are starting from here. X plus 2 minus 2x. It is not different from 2 plus x minus 2x over 2x squared (1 minus x raised to the power 1 times 1 minus x raised to the power minus half. Law 1, that says 1 plus minus half is equals to half. So you have 2 over x minus 2s is equals to minus x. Then you have 2x squared 1 plus law 1. This is identical to this, so you apply law 1. That says 1 plus minus half is equals to half. So it becomes 1 minus x raised to the power half. That is the answer. So this is a complex form of indices that possibly you can ever come across with. Take your time to copy it, and we'll take the next question. Remember, this is we continue from section 1. We started from section 1, and we continued on section 2, and because of the space, we came to section 3. So you start here, and then you come here, and then you come here. Take your time to copy it. This is video. You can pause it while you are copying it. Thank you. In this next question, it says that simplify x raised to the power negative half multiplied to x minus 1 raised to the power half plus x raised to the power half multiplied to x minus 1 raised to the power negative half all over x raised to the power half. Let me double check it. X raised to the power negative half, correct? X minus 1 raised to the power half, correct? Plus x raised to the power half, correct? Multiply to x minus 1 raised to the power negative half, correct? All divided by x raised to the power half. Good. Just like what we did previously, I can take the whole term, this one, and clone it here. Or I can take the whole term, this one, and clone it here. Or I can take this one and clone it here. Whichever, that will make the algebra much easier, is what I think we have to do. If you watch closely to this question, or to this expression, you can see that I'm picking this one to make the algebra much simpler. I'm picking this one, and then if I pick it up, I will clone it. So x minus 1 raised to the power, you see that it is negative half. Because I'm cloning it, I'll make it positive. So it becomes, and I'll do the same thing by dividing. Honestly, this expression here is no different from this one. By any means, this one can cancel out. This is just an algebraic manipulation. And this is how we do it. This type of cloning system, I call it cloning system. But in plain English, you may call it rationalization. It is also possible. So this one, I'm going to multiply this term to this one, and multiply it again to this one, and multiply the denominator, this one, to that one. So you can see that the expression is not different from x raised to the power negative half times x minus 1 raised to the power half. Then this one is coming to multiply to 8, so it becomes times x minus 1 raised to the power half. Then I have the plus over there. X raised to the power half, x minus 1 raised to the power negative half, multiply to that one. Then we come to the denominator. This one, x raised to the power half, being multiplied to x minus 1 raised to the power half. You can see that this one and this one are identical, so I will apply the law 1. As you know, applying the law 1, it becomes x raised to the power negative half x minus 1 half plus half. Then the plus comes there. X raised to the power half, this one, multiply to x minus 1, the same law 1. Remember, law 1 says that m multiplied to an is equals to am plus n. Just for you to remember, we are not doing anything different than quoting the law. So this one minus half plus half. Then we come to the denominator. The denominator, x raised to the power half multiplied to x minus 1 raised to the power half. Good. You see, then we have x raised to the power negative half multiplied to x minus 1. Half plus half is equals to 1. You can write 1 here, or you can leave it like that. For instance, if you have let's say a raised to the power 1 is equals to a. If you have 21 raised to the power 1 is equals to 21. If you have 37 raised to the power 1 is equals to 37. So x minus 1 half plus half is equals to 1. S raised to the power half. S raised to the power 1. It is equals to s minus 1 raised to the power 1. It is equals to s minus 1. So it is nothing different. And then we come here. S squared, s raised to the power half, multiplied to x minus 1 raised to the power negative half plus half is equals to 0. All over x half multiplied to x minus 1 raised to the power half. If we continue, let's say we call this one section 1, and we call this one section 2. Call this one section 2. Good. Picking up from here, we can see that what we are dealing with, we have x raised to the power negative half multiplied to x minus 1, and then plus x raised to the power half, any number raised to the power 0 is equals to 1. And then we have here x raised to the power half multiplied to x minus 1 half. Good. You take your time to copy. We'll continue. We can see that significantly there has been no progress. The same thing I mean, there has been no progress. There's a reason why I did that, and I will explain it to you later on. Now, because there has been no progress, all what we can do is to pick a simpler one and clone it. So this one, I'll make it s raised to the power negative half, which is this one, multiplied to x minus 1 plus x raised to the power half, all over x raised to the power half multiplied to x minus 1 raised to the power half. Then I'm going to clone it. I'll use the simpler term. So I pick up this one and clone it here. So it becomes s raised to the power negative half over x raised to the power negative half. Good. So it becomes, I'm multiplying this to this and this to this. So it becomes x raised to the power negative half x minus 1, and then x raised to the power negative half plus x raised to the power half times x raised to the power negative half. Good. All divided by x raised to the power half, which is this one, multiplied to x minus 1 raised to the power half times x raised to the power negative half. Good. This is no different from x raised to the power negative half, which is this one, and I'm bringing that one here. X raised to the power negative half. And then this is plus, sorry, plus x raised to the power half log 1 minus half divided by x raised to the power half, which is this one, multiplies to x raised to the power negative half multiplied to x minus 1 negative raised to the power half. Good. This one and this one log 1. So it becomes minus half plus minus half is equals to minus 1. So it is equals to x raised to the power negative 1, this one and this one, log 1, plus x raised to the power half minus half is equals to x raised to the power 0 over x raised to the power half times x raised to the power negative half is equals to x raised to the power 0 multiplied to x minus 1 raised to the power half. Good. There's a space there still. So this one becomes x raised to the power, becomes 1 over, it becomes x raised to the power negative 1 plus any number raised to the power 0 is equals to 1 plus 1 over 1 is raised to the power 0 is 1 times x minus 1 half. Good. Can I borrow somewhere? Can I borrow somewhere? So you can see that, let me borrow this section. Let me borrow, I'm thinking of where to borrow. Board is full. Let me clean here. Let me borrow here. Anyway, it is video. You can take your time. You can pause it. Take your time. And I mean, and then copy everything. Okay, I'll call it session 3. We left up with here, so it become 1 over x raised to the power -1 is the same as 1 over x, plus any number raised to the power 0 is equals to 1. 1 over plus 1 all over x minus 1 raised to the power half. You cross multiply, so it become 1 plus x over x minus 1 raised to the power half. This should be the answer. I think there was a mistake over there, which we have to clean it up. So this one is equals to x raised to the power, this one, negative half. I'm bringing this one here to make x raised to the power negative half. And we have here x minus 1, and we plus x raised to the power negative half plus negative half is equals to 0. All over, we are bringing this one here, x raised to the power half times x raised to the power negative half multiplied to x minus 1 raised to the power half. Good. This one and this one, okay, let's do it this way. It becomes x raised to the power negative half multiplied to x raised to the power negative half. We have x raised to the power negative 1. Then we have here multiplies to x minus 1. Good. Plus any number raised to the power 0 is equals to 1 over x raised to the power half multiplies to x raised to the power negative half is equals to 0. Is equals to x raised to the power 0. X raised to the power 0 is equals to 1. Then times x minus 1 half. Good. Then we borrow a space here. We have here x raised to the power negative 1 is the same as 1 over x multiplied to x minus 1. which is this one, plus 1 all over x minus 1 raised to the power half. This one you can cross multiply this one to that, so it becomes x minus 1 plus 1 multiplied to you are cross multiplying 1 multiplied to x all over x minus 1 half. So it becomes x minus 1 plus x over x minus 1 half is equals to 2x over x minus 1 half. That should be the final answer. Take your time to copy it. Yeah. That should be the final answer. Take your time to copy. Ah, 2x minus 1, sorry. 2x minus 1. Yeah, that's the final answer. Good. Now, the same question that we solved, there is also another simpler question, another simpler strategy that we can use to solve the same question. Remember, the question was given us x raised to the power negative half multiplied to x minus 1 raised to the power half plus x raised to the power half multiplied to x minus 1 raised to the power negative half all over x raised to the power half. Let me double check it. X raised to the power negative half, x minus 1 raised to the power half, plus x raised to the power half, correct? x minus 1, correct? Raised to the power negative half, correct? X raised to the power half, correct? Good. Remember, I said we can choose this term, or we can choose this term and clone it. Whichever term that you use, but always the simpler term is the best. You see how, in the algebraic analysis, we had, so much, algebra to go through because of the term that we choose. The choice of a term that you choose matters a lot. Then why don't you take simpler term to clone it? In our previous approach, we choose this one. Why didn't we choose this one? I was just trying to say that the simpler term always the best. And you can see if I choose this one to clone it, we will go so faster than the other strategy that we used. So I'm going to choose this one to clone it. So this expression, x raised to the power negative half over x raised to the power negative half. The same, I've cloned it. This expression is no different from this expression. By any means, this one will cancel this one out. Now, look at it. It becomes this one multiplied to this section. So it became x raised to the power negative half multiplied to x raised to multiplied to this one, x raised to the power negative half. Then this one comes along, raised to the power half, plus x raised to the power half multiplied to this one, then this one comes along with s minus 1 raised to the power negative half. Then we have a common denominator, which is s raised to the power half times x raised to the power negative half. Law 1. We have this one and this one. Using law 1, it becomes x raised to the power minus half plus minus half is equals to minus 1. Then this one comes along. We have s minus 1 raised to the power half plus which is this one, law 1, x raised to the power negative half minus half, this one. And then this one comes along with it, have negative half. All divided by x raised to the power half law 1 minus half. So we have x raised to the power negative 1, x minus 1 raised to the power half, plus half minus half is equals to 0. We have x raised to the power 0. Then we have here x minus 1 minus half divided by x raised to the power half minus half is equals to 0. So we have x raised to the power negative 1, x minus 1 half, plus any number raised to the power 0 is equals to 1. 1 multiplied to x minus 1 raised to the power negative half all over 1. So I'll call this one section 2. Pick it up. We have x raised to the power negative 1, x minus 1 raised to the power half plus x minus 1 raised to the power negative half. All over 1 means the same. This one can be also expressed as x minus 1 raised to the power half over x plus this one. Remember, I said that a raised to the power negative 1 is equals to 1 over a. Remember. So this one is no different from 1 over x minus 1 half. You cross multiply. So it became this one multiplied to this one multiplied to this. So we have x minus 1 half multiplied to x minus 1 half plus this one to here, 1 times x all over x minus 1 half. Lower 1, x minus 1, because this one and this one are identical, half plus half plus x. Then you have x minus 1 half. Half plus half is equals to 1. Then you have x minus 1 plus x all over x minus 1 raised to the power half. Then you have x plus x minus 1 over x multiplied to x minus 1 half. Then you are left up with, is there any space? Yeah. You are left up with s plus x is 2x over x minus 1 half. The same as the previous answer. Let me do it correct. Yeah. So it matters a lot which term that you take to clone it or to rationalize it. So this is how it is. Take your time to copy, and we'll take the next question as well. Yes, there is another question also to consider. It says, simplify x minus 1 raised to the power half plus x minus 1 raised to the power negative half all over x minus 1 raised to the power half. We will do the same thing as we did previously. I'll pick this one to clone it, or I'll pick this one to clone it, whichever way. They are both, I think, simple. So let's pick up this one. So it becomes x minus 1 raised to the power, I'm cloning it, so it is negative here, so it will be positive. All over x minus 1 raised to the power half. It becomes, this is multiplied to this, we are multiplying this to this, multiplying it to that, multiplying it to that. So it becomes x minus 1 raised to the power half being multiplied to x minus 1 raised to the power half plus x minus 1 raised to the power negative half being multiplied to x minus 1 raised to the power half all over x minus 1 raised to the power half multiplied to x minus 1 raised to the power half, which is not different from lower 1, x minus 1 raised to the power half plus half plus x minus 1 raised to the power negative half, the same, log 1 plus half. Good. And the denominator become x minus 1 raised to the power half, the same, log 1 plus half, which is not different from x minus 1, which is that half plus half is equals to 1 plus x minus 1 minus half plus half is equals to 0 all over x minus 1 raised to the power half plus half is equals to 1, which is not different from x minus 1 raised to the power 1 is still the same, plus any expression raised to the power 0 is equals to 1. Then we have x minus 1, which is not different from x minus 1 plus 1 is equals to x, because this one cancels out, become x over x minus 1. So simple. Let's check it. Yeah. For instance, assuming you were requested to, let's say, differentiate with respect to x, expression like y is equals to x minus half, x minus 1 raised to the power half plus x minus 1 raised to the power negative half. Let's make it neater. Raised to the divided by x minus 1 raised to the power half. Of course, in A levels, this one can be, you can be requested to differentiate such expression. If you are given such expression to differentiate, it becomes so, strange. To do that, you have to go through the whole process and then come to the point that y is equals to x over x minus 1, or x minus 1. When you can do it to such form, it becomes easier to use the quotient rule of differentiation to differentiate this one. Or in some case, you may be requested to integrate this expression. And in that case, if you are requested to integrate x minus 1 raised to the power half plus x minus 1 raised to the power negative half over x minus 1 raised to the power half dx. And maybe you've been given an integral limit to be, let's say beta, and that one is alpha. This can be strange, not until you clean up everything and you conclude that this integral is no different from beta is equals to s over x minus 1 dx. Yeah, that's it. So you can see the use of such kind of algebra, how helpful it is to be able to do such kind of algebra in order to do some algebraic analysis. Take your time to copy it, and you can pause it to copy everything. Let's take past question, which was June 2007, and the exam board was OCR, MEI structured. Either OCR or AQA or Edicel, they are all the same, whichever. They are all the same. So the first one says that find A, given that A cubed is equals to 64 raised to the power 12 multiply 64 multiplied to x raised to the power 12 multiplied to y raised to the power 3. And the second one says find the value of half raised to the power negative 5. Each one of them is 2 marks. See how we can do it. Solution. Solution 1. A raised to the power 3 is equals to 64 multiplied to x raised to the power, correct answer, x raised to the power, correct question, x raised to the power 12 multiplied to y raised to the power 3. This is no different from A. If I'm making A the subject, then it will be 64 times x raised to the power 12 multiplied to y raised to the power 3, or into bracket 1/3. Why? I'll tell you why. If you have, let's say, x raised to the power n is equals to y, then it is no different from y equals to s equals to y raised to the power 1 over n. If you have f equals to, or fx equals to d, then f is equals to d raised to the power 1 over x. So it is the same. When you have a raised to the power 3, and if you want to make a the subject, it goes to the right hand side and it becomes an index as well, but it is being reciprocated. So this one, but remember A is equals to, what is 64? 64 is 4 times 4 times 4. So 64 is equals to 4 raised to the power 3 multiplied to x raised to the power 12 multiplied to y raised to the power 3, all have a common index of 1 over 3. Remember, I think it was law 4. Law 4 says that if you have A multiplied to B like this, it is no different from AN times BN. We are using the same law here. So it becomes A is equals to 4 raised to the power 3 times 1 over 3 times x raised to the power 12 times 1 over 3 times y raised to the power 3 times 1 over 3. This one will cancel this one. This one will cancel this one to have 4. This one will cancel this one. So we are left up with A is equals to 4 raised to the power 1, which is 4, multiplied to x raised to the power 4, multiplies to y raised to the power 1, which is 1. So this is the answer. Good. And the next question, which is part B. The part B question says that find the value of half over half raised to the power negative 5. We can do away with the negative index, so it becomes 2 over 1 raised to the power of half, raised to the power of 5, sorry, raised to the power of 5. To do away with the negative index, you reciprocate the fraction. So it becomes equals to 2 raised to the power 5, which is no different from 2 times 2 times 2 times 2 times 2, which is equals to 32. So this is the answer. So simple. Within a short period of time, you've gained 4 marks. We are taking another question. This is a question. June 2008. June 2008. It says, 1. Find the value of 1 over 25 raised to the power negative half. 2. Simplify. 2x squared y cube z all raised to the power 5. Good. Solution. One over 25 raised to the power negative half is no different from 25 over 1 raised to the power half, which is equals to 25 raised to the power half. This is the same as the square root of 25, which is equals to 5. Or you can do it this way, to say that 25 is equals to 5 times 5, which is 5 squared, raised to the power half, which is not different from 5 raised to the power 2 multiplied to 1 over 2. That was the fourth law. A, B, N is equals to A, N, B, N, or A, N, M is equals to A, N, multiply M. The same. So this one cancels this one. You are left up with 5. So either that way or that way. But I need the space to do the second question. Yeah, the second one says that 2s squared multiplied to y cubed multiplied to z all raised to the power 5. Remember, that was the law 4. Applying the law 4, it becomes 2 raised to the power 5 times x raised to the power 2 times 5 times y raised to the power 3 times 5 times z raised to the power 5. So you have 32 multiplied to x raised to the power 10. Oh, sorry. Yeah, correct. Multiplied to y raised to the power 15. Multiplied to z raised to the power 5, which is no different from 32 x raised to the power 10, y raised to the power 15, z raised to the power 5. That's it. Take your time to copy. Good. This question is June 2010. Write down the value of each of the following. A, 4 raised to the power negative 2. B, 9 raised to the power 0. Find the value of 64 over 125. Let me see. Yeah, they are correct. Good. Solution. A, 4 raised to the power negative 2 is no different from 4 negative 2. It's no different from 4 over 1 negative 2, which is also not different from, to do away with the negative, you reciprocate it. It becomes 1 over 4 raised to the power 2, which is equals to 1 over 16. B, 9 raised to the power 0 is equals to 1. So simple. Any number raised to the power 0 is equals to 1. 45,000 raised to the power 0 is equals to 1. 700 million raised to the power 0 is equals to 1. 5 raised to the power 0 is equals to 1. Any expression raised to the power 0 is equals to 1. So the first part is done. Comparatively, if you, if you compare the A-level, indices, they are always the question can just like this. comparing to those complicated indices algebra that we did, comparing to this one, you can see that, in fact, A-level indices are very cheap. I mean, they are very, very easy comparing to those complex one that we did. Okay. Then we come to the second question, which is find the value of 64. Let me see whether the question is correct. Yeah, it's correct. 64 over 125 raised to the power 4 over 3 is no different from, what is 64? 64 is 4 times 4 times 4, which is 4 raised to the power 3. 64 is equals to 4 raised to the power 3. What is 125? 125 is 5 times 5 times 5, 5 raised to the power 3. They all have common index of 4 over 3, which is equals to 4 raised to the power 3 multiplied to 4 over 3 all over 5 raised to the power 3 multiplied to 4 over 3. This one will cancel this, and this one will cancel this. So we have 4 raised to the power 4 over 5 raised to the power 4. You use your calculator to calculate it. Yeah. So cheap. Let's try another one. The next question, it says, find the value of each of the following. I mean, good. Which is June 2, 2013. Solution. One. 5 over 3 raised to the power negative 2 is not different from 3 over 5 raised to the power 2. We have done away with the negative sign, therefore we have turned the fraction upside down. So it is equals to 3 squared over 5 squared, which is equals to 9 over 25. Answer. The second question, it says that 81 raised to the power 3 over 4 is not different from 81 3 over 4. But 81 is also equals to 3 times 3 times 3 times 3, which is equals to 3 raised to the power 4. So it becomes 3 raised to the power 4 into bracket 3 raised to the power 4, which is equals to 3 raised to the power 4 multiplied to 3 over 4. This one will cancel this one, then you are left up with 3 raised to the power 3, which is equals to 27. Therefore, 81 raised to the power 3 over 4 is equals to 27. So simple. This is the type of A-level questions, the type of A-level question on indices that you may have to expect. Take your time to copy, and we'll take another example. Now, we are moving to the next section on algebra, which is 1-2. Expanding brackets. expanding brackets. If you have, for instance, x plus 3 multiplied to x plus 2, it is no different from x times x, which is x times x, x times 2, sorry, x plus x plus x times x, which is this one, x times 2, which is x times 2, then you come to this one, plus 3 times x, then plus 3 times 2. So you have s times x is s squared plus 2x plus 3x plus 6. This and this is equals to 5x, which is equals to s squared plus 5x plus 6, which means this expression s plus 3 multiplied by x plus 2, we have expanded the bracket. This, talks about expanding bracket. Expanding brackets. So the left-hand side has been expanded to this one. I think this is very, very cheap. But we'll take some practical question. Practical question on such topic. The next question that we are considering is this one. It says that find the area A2. The area A2. Meaning the area A2 is this area. Everything. This kind of question, practically you can find such kind of analysis on machine design. You can find such analysis on construction sites, whereby in order for the engineers to make very decisive analysis, they have to come with an idea. For instance, if they are looking for area A2, given that the area A1 has been given and the entire area has been given, you can find such analysis, on construction site. You can also find it in a place where, on mechanical engineering area, where machine is being designed. Okay, we are requested to find A2. We will say that the entire area, which is the whole area, this times this, the whole area is equals to AT is equals to A1 plus A2, the whole area. A1 plus A2. I'll call this one equation alpha. But A2, but AT by definition is equals to this times this. X plus 8 multiply 2, 4x plus 2 minus y. I'll call this one equation beta. Also, the area A1 is equals to length times breadth, which is, let's say x minus 1 times x minus 3. Good. I'll call this one equation gamma. Putting beta and gamma into equation alpha, you see A1 is equals to this. A2 we don't know. A3, AT is this one. So putting equation beta into putting equation beta and gamma back into equation alpha, you have putting beta and gamma into alpha. You have AT, which is x plus 8 multiply 2 4x plus 2 minus y is equals to A1, where A1 is equals to x minus 1 x minus 3 plus A2, which implies is making A2 the subject. A2 is equals to x plus 8 times 4x plus 2 minus y minus x minus 1 x minus 2. A2 is equals to x times 4x, you have 4x squared, x times 2, you have plus 2x, x times minus 1, you have minus xy. Then you have 8 times 4x, you have 32x. 8 times 2, you have plus 16. 8 times minus 1, you have minus 8y. Minus s squared minus 2x minus x plus 3. Good. This one is no different from 4x squared plus 2x minus xy plus 32x plus 16 minus 8y minus x squared plus 2x plus x minus 3. Grouping the like terms together, we have 4s squared minus s squared plus 2x plus 32x plus 2x plus x good. Then we have sy term. There's only one here, but minus xy minus 8y plus 16, the constants, minus 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for s squared minus x squared, we have 3s squared. 2x plus 32x becomes 34x plus 2x becomes 36x plus x 37. 2, 2, 2, 32, 34, 36, 37 plus 37x. Have 3 here. We have good. Then we have minus xy minus 8y plus 16 minus 3 is equals to plus 13. Or we can say 32s squared plus 37x minus y x plus 8, we have factorized the y outside, plus 13. This is the area. This is the area HU. HU, therefore, measured in square units. That is HU. I hope we did everything correct. But anyway, that is how the analysis goes on. Good. Let us take another example. The next question, it says, find the volume of a cuboid whose dimension is, find the volume of a cuboid whose dimension is x plus 3 centimeters (3x minus 1 centimeter) plus 6x plus 2 centimeter. Good. Solution. Assuming this is the cuboid, and let's say this one is this length is 6x plus 2 centimeter, and let's say this one is 3x minus 1 centimeter, and let's say this one is x plus 3 centimeter. Volume is equals to length times breadth times height, so we can multiply. Let's say 6 plus 6x plus 2 centimeter multiply to 3x minus 1 centimeter multiply to s plus 3 centimeter. Volume is equals to 6x plus 2, 3x minus 1, x plus 3, centimeter multiplied to centimeter multiplied to centimeter is equals to centimeter raised to the power 3, which is called centimeter cube. Then we do a systematic expansion. We have six x plus 2 3x volume 3x minus 1 multiplied by s plus 3 all in centimeter cube. Six s multiplied to 3x, we have 18s squared, 18s squared. 6s multiplied to 1, we have minus 6x. 2 multiplied to 3x, we have plus 6x. 2 multiplied to minus 1, we have minus 2. Then all multiplied to s plus 3. Then we have centimeter cube, which is equals to 18s squared minus 6s plus 6s is equals to 0. Let's double check it. 18x minus 6s plus 6s, correct, minus 2. This one will cancel this one, so we have minus 2 multiplied to x plus 3 all centimeter cube, which is equals to 18s squared multiplied to x. We have 18s cube. 18s squared multiplied to 3x, we have 18 times 3, 18 times 3, 24, 54. We have 54s squared. Minus 2 multiplied to x, we have minus 2x. Minus 2 multiplied to 3, we have minus 6, all in centimeter cube. Therefore, the volume of the cuboid is 18x cubed plus 54x squared minus 2x minus 6 centimeter cube is the volume. Good. Let's double check it. 6 this should be the end of section 1-2, expanding on bracket, and we will jump next time to section 1-3.